And this is where the idea of ontologies come in. This is an ontology from a textbook from MIT. And it's a very simple one, extremely simple one here. But it's an ontology for the domain of camera. So we say that of camera, there are the types digital and film. And of digital, we have SLR and point and shoot. We have synonyms for SLR, single lens reflex, SLR camera. We have attributes of SLR. Now, before we had things like ontologies, if you were interested, for instance, in an SLR camera and you went to the web and you did a search on SLR, you would come up with websites that the string SLR appeared on. But you would not see the websites that said single lens reflex if it did not say SLR as well. So the idea here is that based on meaning, you can become much more targeted and go much further into what's available on the web. It facilitates a much more insightful kind of use of information. And so this definition of ontology comes from an article. And the most interesting thing to me about the citation is the first name in the authors list, Tim Berners-Lee, who many people recognize as the originator of the web. And he's very much gone into semantics in recent years. So the application of ontologies to the information that's on the web is, roughly speaking, is what we call the semantic web. Now, this is an example of a semantic search engine. And so I typed our favorite string into this one. And you see, of course, it can't read my mind, so I do get a lot of hits on different matches to the word Ada. But eventually we get down to the one that's of interest. And as I click on that, now it says it applies the ontology, and then the list that comes up is laser directed to my interest. I don't get any superfluous hits. It's all just exactly what I'm interested in. So, with the semantic web, we ask the web questions, and in a limited way, it sort of understands what we're talking about based on these patterns that we call ontologies, and then it gives us more useful answers than we would have had otherwise. But there's a holy grail in the semantic web. Some people think of this as Web 3.0. Some people think of this as Web 4.0. But the idea here is intelligent agents that can act more or less independently of what we say. They can go out and mine the information that's out there, discover their own patterns, come to their own conclusions, and feed them back to us. Like Agent Smith in The Matrix. Of course, he unfortunately came to some conclusions that human beings were not very happy with. But in a sense, this is what some people talk about in the dialogue about where the web is going. So the web talks to us. I call this the unobtainium web, for reasons that we will get into here shortly. So here's a kind of a nice map that summarizes the thoughts on the various stages of the web, assuming that Web 4.0 is where we're going. But the interesting thing about all this is it's sort of based on a worldview that things are pretty predictable. Noam Chomsky said many years ago that there were deep structures in the brain that correspond to language. So if you can find those deep structures and reflect them in patterns, like for instance ontologies, then you can exploit that. And it's a very powerful thing. Unfortunately, what cognitive science has discovered in the years since then is that the brain really does not have these deep structures. that there are no pre-programmed language patterns in the brain, that they're very flexible. So when we're developing systems, we develop these lovely systems, you know, like this beautiful red convertible, and then we sell them, and human beings get in them with all of their mixed motives, all of our mixed motives, and so forth, and kind of commence messing things up. And not only are the systems that we develop, not only are they complicated by the fact that the humans use them, but the systems that develop those systems, our organizations and so forth, also have human beings in them with unanticipated side effects at all times. And everywhere we look, there's humans, 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 sort of mucking things up. Now, this is a very famous author. I'm sure many of you have heard of him. He applies cognitive science to improving the productivity and efficiency of people. And he did a presentation. This is one of the most widely viewed presentations on the web. It was animated by a group called the RSA. And there's well over 1 million views of this. I've done some screen captures from it here, where he was talking about a study that came to the conclusion that human beings are not as predictable as we would assume. A study was done at MIT. Students were given various kinds of tasks, from very simple, like shooting basketball hoops, on through very complicated tasks. And the point here was to test a very powerful pattern of belief here, and two principles. One is that if you want more of a particular kind of behavior, you provide more rewards. And if you want less of a particular kind of behavior, you provide certain punishments. And so the idea here is that if somebody did, a little bit on a task that they were given, they get a little reward. If they did more, they get more of a reward. And if they really did well, then they would get a massive reward. And the emphasis here, of course, is on the top performers. This is found all through organizations and even in movies. Now, what they actually found was that when the tasks were very mechanical and simple, that actually worked that way. The more that you paid, the more behavior that you got. However, the instant that you had to begin applying more cognition, it went the opposite way. More reward led to less behavior. Now, how could this be? Well, cutting to the chase, it's the same thing that Maslow told us a long time ago, which is rewards are motivating until you get to a certain point where all of your basic needs are met. And after that, it's other things that motivate people. We're driven by purpose. And the thing about purpose is that purpose varies from one person to the next, even in the same person, from context to context, from one group to the next group. It varies all over the place. So this is a friend of Galileo's, Cardinal Bellarmine, and he was writing a letter to a mutual friend of both of theirs. And in this letter, he was telling this friend, you know, this notion that Galileo has, that the Earth revolves around the sun, that's just fine. Mathematically, it makes a lot of sense. You know, you can work the math very easily, more easily than in the notion that the sun revolves around the Earth. But what's really dangerous is if you actually try to change the pattern. If you try to say that it's really true that the Earth revolves around the sun. And this has actually become known as the Cardinal Bellarmine effect, which is that the pattern trumps the data, the facts, and overrules it. So what we see here is that in the web, the temptation is to take ontologies, which are patterns, and say that they have some sort of almost magical quality of rightness and apply them to all of this diverse information with human effects and so forth, and say that the pattern explains everything. And where that leads us to is some interesting places, and this is just essentially basic human nature. For one thing, we like to look for simple causality. So for instance, in this picture, Mr. Sun has just been awakened by Mr. Rooster's crowing. It's obvious. It leads us into things like jumping on bandwagons, particularly powerful patterns that have a lot of traction in our context, our culture, and so forth. So we find us a band and a good wagon, and we jump on board. Then we take new information and we say, here's my pattern. The pattern is that the sun revolves around the earth, so therefore this new information must fit in my existing pattern. And so it goes. And then when we're finally confronted with our existing pattern just is broken, it just won't do it, then we set out on a quest looking for another stable pattern to replace it. By the way, that is the most popular quilting pattern in all time. This began to be addressed around the beginning of World War II by Alan Turing, who we all know, of course, is the inventor of the concept of the universal Turing machine, which virtually all computers today are still based on that approach. And he was in the Station X project at Bletchley Park developing a computational machine to break the German codes more quickly. The Poles had actually developed the algorithm for breaking the German codes in the late 1930s, but it wasn't fast enough to use the information tactically on the battlefield. So what Station X was doing was developing something that became actually known as Colossus after a while. And in the course of doing this, as he was thinking about the issues involved, he came to this understanding. He said, we now know that some kinds of systems cannot be developed using fixed or formal processes. So what you can think in terms of that would be existing patterns, right, that we apply to those problems. And he said those are called complex systems. And so one of the things that really fascinated him was what happens when an egg is fertilized. So initially it divides into identical cells, but then as the division continues, they begin to differentiate, and you see different structures and so forth, as this video demonstrates. And he wrote a very influential paper in which he discussed this phenomena. And he said, about systems that start out, they look homogeneous, but they're really in an unstable equilibrium. And so something happens, some little nudge, and all of a sudden they differentiate into different things than you would have ever expected from the original. And that notion is sort of morphed into the idea that it's useful to classify systems in terms of their complexity. You can think in terms of their relative instability.